We're going to look at 3 different algebraic proofs, and these proofs are all going to be involving a product or a square this time, so slightly harder proofs here. First example that we've got is asking us to prove that the product of an odd and an even number is always even. So the first thing we need to do is actually form the expression, and then we'll think about how we can go about proving that. So we know that we need to think of an expression representing an odd and an even number, and then because we're proving that the product of these numbers is always even, then we need to multiply these two together. So firstly, we should hopefully know that an even number can be represented as 2n, because 2n would represent a multiple of 2, and any multiple of 2 will be an even number. The next thing is to understand that an odd number is therefore any number that follows an even number. So the easiest example here to use would be 2n plus 1. And if we're timesing those two together, then we can write our 2n plus 1 in brackets like that. And we can expand that bracket here to find the product of these two expressions. So expanding our bracket will give us 4n squared plus 2n. And we're trying to prove that this is even. Now, if we're trying to prove that this is even, we need to try and take out a factor of 2. So we're going to factorise 2 out of these two terms. So taking 2 outside the bracket, what times is by 2 to give 4n squared would be 2n squared, and what times is by 2 to give 2n would be n. So that's the bracket, that's what we would get if we factorise 2 out. And we can now write that 2 is a factor, therefore 4n squared plus 2n, the expression that we formed, is even. And if that's even, then we're saying that the product of an odd and an even number must always be even. Okay, so that's the first one that we've got here, proving that they're even. For the second example, it's going to be slightly different, because for this one we are going to be given an expression already. So in this expression we've got 5n plus 2 squared, take away 5n, take away 1 squared, and we're trying to prove that this is always a multiple of 3. Now, if ever we're faced with anything like this, the rule of thumb is to expand everything, to simplify it, and then look at how we can prove what we're looking to try to prove. So in this case, proving that something is a multiple of 3, we're going to want to try and take out 3 as a factor of this expression. But firstly, obviously, we're going to need to expand these two. Now, the key thing to recognise is that if I've got 5n plus 2 squared, that's exactly the same as writing 5n plus 2 times by 5n plus 2. And then we're going to take away 5n take away 1 times by 5n take away 1. So that's actually what we're looking at trying to calculate. Now, we need to expand these two double brackets, and some of you might just be able to do that automatically, understanding here which terms will times by which. Some of you might use grid method to do this. Some of you might use something called FOIL. There's various different methods here for expanding these brackets, but the key thing is we need to make sure we've got the correct expansion here, otherwise our proof won't work. So expanding this double bracket here will give us 25n squared times these two together, plus 10n, which will give us plus 20n, plus 4. And then we're going to take away from this the product of these two brackets. And if we times those two together, we'll get the same. 5n times 5n is 25n squared. We're going to get minus 5n minus 5n, which will be take away 10n. And then negative 1 times by negative 1 will be plus 1. So that's what we're left with. And we're looking at taking this away from what we've got here. So we can see, we can write this in a few different ways. We could get rid of the brackets if we wanted to, but we need to remember that we're subtracting every single term here. Or we can look at the like terms and simplify in that way here. So we've got 25n squared take away 25n squared, which will be 0n squared, so we don't need to write anything down for that. They're going to cancel. Then we've got 20n take away negative 10n, which is exactly the same as 20n plus 10n. So that's going to give us 30n. And then we've got 4 take away 1, which will give us positive 3. So that's what we're left with. Obviously, we're trying to prove that this is a multiple of 3. So we're looking at taking out a factor of 3. And luckily we can see that 3 is an obvious factor of these two terms. So if we factorise 3 out, that will leave us with 10n plus 1. And then we can then explain that 3 is a factor, therefore 30n plus 3 is a multiple of 3. And if this is a multiple of 3, this is the expression we formed from the expression that we were given in the question. So we've proved that 5n plus 2 all squared take away 5n take away 1 all squared is always going to give us a multiple of 3, no matter what value n will take. Okay, that's our second example. And for the third example, this is going to be another one where we're going to need to form an expression. We're not going to be given the expression, we need to form it, we need to prove it. So the question here says that we're trying to prove that the difference between the squares of any two consecutive even numbers is always a multiple of 4. So prove that the difference between, if we're finding the difference between something, we're going to be subtracting them. The difference between the squares, that means we're going to be squaring something, of any two consecutive even numbers. So we need to be thinking about consecutive even numbers. Consecutive even numbers, the first one we'd use normally would be 2n, and then following that would be 2n plus 2, and then following that would be 2n plus 4, and so on. So that is going to be useful. And we're trying to prove that the result of this is always a multiple of 4. So we know at the end of this that we're going to be looking at taking out a factor of 4 in some way. So let's form the expression first. Prove that the difference between the squares of any two consecutive even numbers. So we want to square two consecutive even numbers and we want to subtract them. Okay, now it's obvious that we can just choose these two consecutive even numbers. They're the easiest to choose, and we're going to have a go at then subtracting them. Now this will be the bigger even number than this one. So I'm going to do the square of this number, take away the square of this. So we're going to have 2n plus 2, brackets round it because we've got more than one term, squared. And then we're going to take away 2n squared. So we're finding the difference between two consecutive even numbers squared. And we need to try and prove that this is going to be a multiple of 4. Now, obviously this is exactly the same as 2n plus 2 times by 2n plus 2 take away 2n times by 2n, or 2n squared. So we need to think carefully about how we're going to expand these brackets here before we come to subtract the result of this. So if we expand these double brackets, 2n times 2n will give us 4n squared. We've got plus 4n, which will give us plus 8n. And then plus 2 times plus 2, which is going to give us plus 4. So that's what we get when we expand the double brackets. And for the final step, we're going to take away 2n squared. 2n times by 2n is going to be 4n squared. So we're going to be taking off 4n squared from that. If we look at how we can simplify it, then we can take away 4n squared from 4n squared. They're going to cancel out. And that's just going to leave us with 8n plus 4. And we're trying to prove that this is a multiple of 4. So to do this, we're going to try and take out a factor of 4. Luckily, we can see that 4 is a factor of both these two terms. And if I factorised it out and put this into a single bracket, then we'd be left with 2n plus 1. So we can see here that because we've been able to factorise 4 out, we can see that it is going to be a multiple of 4. So the last thing that I'm going to write now is that 4 is a factor, therefore 8n plus 4 is a multiple of 4. And if 8n plus 4 is a multiple of 4, then what we're saying here is that we've proven that the difference between the squares of any two consecutive even numbers is always a multiple of 4. And that last statement that we've made there is really, really important.